Sure. So then we'll make a start. So today we're going to kind of like take probably 45 to 1 hour, and we're going to make a give a like I'll try to give a quick overview of a cloud and why we are going to cloud and what is AWS, and we'll try to give you kind of a quick overview of AWS, like. Uh, what are the key services and how we can use it, and why industry or the clients are moving to AWS. So those are the things we're going to cover. So as part of this, like we will cover after that a session on Kubernetes as well, and then we will have kind of a working session, demo of like how we can use AWS to host a application. And so with that, we will try to cover some of the basics of AWS, nut and bolt. So trying to give you kind of a quick idea. So just to start, so the idea of this session is not to give you kind of A to Z, full overview of the AWS, but trying to show you why we are moving in, what are the fundamentally the framework behind a cloud, and then like how you can use it so that you can go and start learning. And plus we will share some more the course materials and those things. So there are like so many uh, openly available course materials available, which we can leverage or use to learn in AWS or Azure or even any other cloud. um, so with that in mind, I'll make a start. So the first question we have to ask is why people are moving to cloud, right? So why a particular client moving from their on-premise data centers to cloud, right? So probably you might already have a couple of answers. So like I want you to imagine, right? Just think through, right? So example, if you take any system, if you take any website, if you take anything built on computers or anything, it has to host in some place, right? So example, it has to have a compute power, right? So end of the day, it has to be either like a very sophisticated hardware equipment, or it can be any other kind of like a hardware device, but it has to have its base mainly uh, processing, right? So you have to have processors to do the processing, and then you'll have to have kind of a storage, right? Because whatever the data, the file, objects, and those things that we have to store someplace. Then you will have to have a network, right? So the network is also very important because it will connect you to internet, intranet. So basically, this in nutshell, you need to have compute power, and you need to have a storage, and then you will have to have a network to enable this, right? So early days, from the time where computers are built, and when we start using intranet, and then born of internet, and what happened is with all of this, we used to have our own servers, and then we put our website system into those servers and enable that access to the relevant people. So example, if you consider a particular website, it is something hosted in a particular physical server. So when it comes to the large clients, and the other the places where they are spending money and they want to have more security, they want to have more control of their data. What used to have is they used to build a data center. So data center is uh, probably like maybe very similar to a computer lab, right? So in your lab you have set of servers, and then you might have your air condition, because what you call the temperature is very important to control. Then you will have your networking, wiring. So it's all, and then based on that you will have your processing, you will have your storage. So we call capacity and all. So basically it's all about the physical things. So in those times, if I want to add more power, like I want to assume that I host a particular website which is being accessed by 10,000 people, and suddenly my marketing team comes and say, we are doing a campaign, and we are expecting that there will be 20,000 people will access your site, right? From our experience, probably we might have to get ready for around 25,000 people, right? So that means we need more capacity, right? So that existing server, which was developed to support 10,000 users, with that amount of memory, CPU, storage, is not able to support that, right? So that we have to go and add more the processing power, we have to add more storage, we have to add more networking bandwidth and all. So those are the key things, right? So when early days, like if I had that kind of requirement, then what we used to is we will do kind of architecture analysis. We will say this is the latest compute power, storage and other requirements, and we will give it to the data center team. They will have to procure the hardware, and then they will procure from the vendors. Then the vendors will courier and transport and give it to the data center. And some instance, we have to get those vendor engineers to come in, visit that on premise, go and plug that, put that cable, switch it on, get it up and running. So that's a lot of work, and plus it take a lot of time. So those are not easy, right? It's in all lot of planning, and it's the cost is very high, and especially, and there's a lot of manual involvement, right? So based on this, after sometimes people realize that this is a very tedious work, and the investment the companies are putting for this is very high. So what they have done is they want to move from traditional kind of like this on premise to a cloud. So cloud is nothing but someone comes and say, look, example, assume that we all want to create to get into this industry, right? As a cloud service provider. So what we will do? So we will probably get a couple of processors, storage, networking, and other services. And then based on that, we will create a setup, and then we'll tell people, like, look, you come here, and then you can host your system, your application with us. And so in early days when the cloud started, there people have a lot of reservations, right? So people are worried that okay, how cloud is a good idea, right? So they people understand the cost benefit, right? Instead of I'm managing uh, the data center, I'm keeping a security, I'm managing the physical security of these servers, or I'm managing the maintenance, the patching, and all those things related to servers. Now I just buy some storage and capacity from a cloud service provider. I quickly set up and I'm good to go, right? So that is definitely face value looks like a very good solution, but people are thinking that so what about data? So my data is exposed to other people. So if I'm sharing a server, right? So example, if we create a virtual machine, if that machine is hosted in underneath the physical server where there are multiple other virtual servers are being spawned off and then provided to different clients, so how are we securing our data? So those example, security was one of the major factor, like reservation why the industry or the clients are not willing to move into the cloud, right? And over the years they have a lot of development, they have a lot of improvements in this area, and people have the cloud service providers have improved their security, the way they are operating. So this resulted in the cloud being a very attractive uh, attractive opportunity, right? Instead of we spending money on premise, uh, going to cloud will automatically save a big percentage of our initial capital, right? So if you look at a few things I have noted down. So one thing is simple and quick setup, right? So example, if now uh, if you ask me, Indika, we have a website, we can you put it into a machine, and then we will deploy that, put that content into a database, and then we will create a domain URL, and then we'll release that website into internet. Maybe with the cloud service providers like AWS, it will take maybe 5 to 10 minutes work, right? So it's just matter of provisioning uh, what we call instance, a virtual machine, and then we simply going and configuring our servers and other things and deploy, and then we purchase a domain URL, and then we are good to go, right? So that's kind of like a maybe 10 to 20 clicks maximum, and the time will be probably 5 to 10 or 15 minutes, if assuming you already have an account, and that's straightforward, right? But if you consider some time back in a traditional world, in your on-premise world, even the things are there, you might still have dependencies with the field engineers, the data center people. And if you are trying to get this done in a kind of a uh, if this is something new, net new resources you are trying to get, then again this will go through that purchasing cycle I mentioned. We give you that our requirement to data center team, they will go and give it to their vendor, they will procure hardware, software, and then someone will come and install that, configure, get it up and running. So that's again, so when compared to that, AWS is very simple, right? So that allow us to a fast way of getting things done. And obviously it has a more shorter lead time. And then there's something called capex, right? So that means like there's no initial investment, right? Assume that we together we start a company, and we think that we'll have to launch a website, right? And then it's not that we build a data center, we get security cameras, we put security people, and we put that, like there's no initial upfront investment, right? It's just that the investment is done by AWS or the cloud service provider. We simply go and use it, right? And again, there are things like uh, example. There's something called pay as you go, right? So example, I don't want assume that I develop a system and I know that around 100 people are using. I don't have to start getting uh, so much of capacity or processing power, right? So I can start small, right? And when I have a feeling that my 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 application is growing, my business is growing, clients are happy, my they are I'm getting more conversion from my business perspective, then I can start slowly increase my capacity, right? Processing, storage, those things, right? So because it's a pay as you go, it's not that I assume that my system will be used by 1,000 people, and I procure hardware software to support 1,000 people, and for 1 year to 2 years I live with around 70 or 80% of less usage, right? So then I'm wasting my money, right? So cloud is that is allow you to identify your demand, and based on that you can go with a pay as you model, right? And the other beauty is it can scale, right? So assume that I develop a system, I assume that only 100 people access, but in back of my mind I think that if my star is good, I can attract 1,000 people. But what if that my star is uh, awesome, and then I attract 100,000 of people, right? In a traditional, in an on-premise data center, that is chaos, right? So you are not expecting your traffic is getting 100x, and you're obvious the the honest answer is you will not be able to scale, right? Because with all those dependency you have in on-premise data center, you will not be able to scale. But with cloud, it's not your problem, right? It's AWS problem. I say AWS, give me this capacity, and then they will give. If I want a more powerful capacity, more storage, it's just couple of button clicks, and then I can get that, right? So the beauty is we are not managing the infrastructure, it's the cloud service provider, in this case AWS is managing. We just have to use it, right? We just have to understand what is our need, right? So why I am using, right? Why I am what sort of requirements I have for my system, right? Based on that I can go and purchase it, plug and play, I may start using it. If I assume that initially I thought that my system is going to use by 1,000 people, and then I purchase and I do I build a system for 1,000 people, but it's a failure, right? Some reason I'm only getting 100 people access hits. Probably I can scale down, right? So cloud is you can scale up or you can scale down as well. The so the ability is given. So some people interpret cloud, when we say what is the definition of cloud is, it's kind of like a virtualized environment where based on a console you can do procure your requirement, and you can do a scale up and scale down, right? So these are some other so this covers like why. So this I hope that this gives you the view why it's advantage for organizations to move from their on-premise data center to cloud, right? Because it's not a no-brainer, right? You don't no longer have to manage your physical servers, right? So by moving to cloud, sometimes you can like save probably 50 to 60 or even 70% of your cost, right? And the cost you are incurring, sorry, are very tight coupled to your requirement. It's not that you are wasting resources, right? And even if you identify that some of the resources are not being used, we can scale down so that we have more control, right? So those are the key things why industry is moving to cloud. So almost everyone, right? Even the bankings, big banks, they are moving to cloud because cloud is more secure, right? Sometimes cloud is more secure than our own data on-premise data centers, right? Because the cloud service provider has more money and more technology skill compared to an isolated uh, company, so that they can put this their best footing to secure and provide a greater service, right? So that is typically one of the key things why companies are moving to cloud, right? So what is AWS, right? So AWS stand for Amazon Web Services. So it's again one of another cloud service provider. So uh, it's a collection of a lot of services which is allowing you to uh, 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 do a rapid deployment and get your things up and running and get things into a customer as quickly as possible. So in AWS, we call something called AWS Global Infrastructure, right? So that is their entire uh, set of data centers, right? So they are their systems, so they are hardwares, right? So we call the global infrastructure. So how AWS is running? So they have different regions, right? So they have like India, they have Singapore, they have North America, likewise. So there are different regions, right? So what this allow is that assume that I am developing a system or application. I am launching into uh, customers based out of North America, right? So probably good old days, I would have deployed that in data centers in far away, right? Now with AWS, I am able to figure out a region which is closer to my end users, right? So what that means is that means more fast, right? Response times are much faster, right? So that is the advantage of regions. And then each region is consist of isolated availability zones. We call it, you can assume it's a data centers as well. So example, if you take uh, North US West or East region, it might have its own collection of data centers, but those data centers are isolated. Sometimes definition is that maybe it's 50 to 100 kilometers apart, right? So example, if there's a flood in one data center, it will probably not have a impact on the other data center, right? So that's why how much they want to differentiate or the data centers, so that those are isolated entities. So one thing you have to be mindful is a region is consist of different data centers, right? So when we are going and procuring AWS services, we have the option of selecting a particular region. So that allow us to deploy get our system more closer to our end users, and then we can decide our availability zones as well, right? So one other thing I want to know is this is not only about just deploying our application closer to a customer, right? So this is about disaster recovery, right? So one of the other key theme is disaster, right? Example, if something happened to our data center, what is going to happen, right? So example, if something goes wrong in one of our, assume that this is an enterprise e-commerce application. People are thousands of people are coming every minute or second, uh, purchasing and doing credit card payments, having a shopping carts and all of this, right? So what if that like this the application goes down because of that, the data center goes down, and then the data is lost, right? So the business will have a major impact, right? So first, customers will have a major inconvenience. They will lose their data, and the business will not be able to deliver whatever that they purchase, and there will be a lot of brand name impact. So it's a some companies can go bankrupt, right? Because if your systems are down, right? And assume that this is a the healthcare related system, right? Hospital system. And if this system goes down, patients can actually die, right? So that is that much critical, right? So example, if it is a hospital system and the system goes down, I mean, it will impact uh, probably the ongoing operations. It can impact the future planning, like, the schedules of doctors and nurses and those things. It can impact on the procurement of hospital. It can impact the doctor's ability of going through patient medical histories, right? So it's a major impact, right? What if this is a system used by airline, right? The pilot is flying a plane, and then suddenly the system goes down, so it's not no longer able to connect to central servers, right? Because central servers are down, right? So then that's a so then the, I mean, that's again a industry where the dependency of the system, the IT sector is very high, right? So I hope that now you got the understanding that if the how much critical where we are hosting our data or content is, right? So if that system goes down, we'll have to have a backup plan, right? And it's not that what if that there's a fire, right? So sometimes system goes down, and then probably you can say maybe half an hour, 1 hour after some time we'll bringing it up. So there will be outage. That means your system is down for a particular time, but there's you might have still data, right? But there can be a situation where there's a fire or flood. You lose your entire system, right? So all your data is gone. So that is why AWS coming up with these regions and availability zone, so that you can deploy your system to multiple availability zone, so that you can get more of a uh, disaster recovery resilient, right? So your application is resilient. If one data center is failed, it will not. You can still serve your traffic. So then sometimes some people goes and put your systems into multiple regions, so that in case if there's a one issue with one region, you can still bring up your systems. The systems can be automatically fail over and then be up and running in other region, right? So that is the beauty, right? So that is again one of the major advantage of cloud, right? But assume that if you decide to do that in your traditional data center, right? Then you have your data center in, let's say, Colombo. But if something happens to that data center, okay, then you say I'll have a data center in Mumbai, right? So then what if there's a internet connection failure in, like, the South Asian region, and then you will say, okay, I'll have a data center in USA, right? Washington DC, right? But then that is a lot of money, right? It's very easy to say, but then just having on-premise data centers around the world is that is so much money, right? So companies are not able to afford that. Now, what with cloud, AWS, they are able to afford that, right? So you can have you can have your systems in multiple availability zones, or you can have your systems in multiple regions as well, right? So that way you get more resilient, right? So there are no single point of failures. So that is how we going to address our disaster recovery. So we will have another topic focusing on how we can implement a set infrastructures to uh, be resilient and fault tolerant systems, and how we can build systems with disaster recovery capability. So AWS is providing a lot of services that will allow us to do that, right? So then one other thing is edge location, right? So assume that you are having a you are hosting content, right? It might be images or videos, right? So you have deployed this in multiple data centers or multiple regions, right? So if someone outside these locations try to access, or even this location, that request. So example, if I have a system that is hosted in New York, right? Data center is in New York, and if I'm from Colombia and I type that systems probably URL and press enter, the request will travel through the internet around the world, and it's been served from data center in New York, right? So that is, I mean, that is how the internet is working, right? So then even then there can be a lot of delays as well, right? So then even though assume that even in New York, there it's a, like, it's still a large state, right? So then AWS has come up with something called edge locations. These are more of a kind of like a isolated locations in different part of world, where they can cache your content and data, right? So that when the request is there, it will look at the nearest edge location, and then from there it will try to serve traffic, right? So that is a fast way of providing response to end users, right? So in a nutshell, AWS global infrastructure is based on regions, availability zones, and edge locations, right? And when it comes to like the foundation services, right? So as I said, like, you don't have to look at far away, but look at this laptop, right? Probably if you are joined this call from a laptop. So laptop, what are the foundation services in a laptop, right? First thing is its processor, right? So that is doing the computation, right? Your processor, that's the most important thing. Then the your storage, right? Your C drive, D drive. Then some people will have your the pen drive, and some people have a uh, your extended hard drive as well. So the storage is very important, right? Then your networking, right? You are, how you going to connect to internet, right? Or maybe you collected in your lab, you connected all your machines and you have created a network, right? So network is very important, right? That's the third thing. And then if you look at this particular system, a database is the next most important thing, right? Because unless you have your the place to store your data, you can't build the complex systems, right? So in simple terms, the foundation service are your compute, which is your nothing but your processing, and then your storage, that is nothing but where are you going to save your data, and then you are networking, right? It's about your network, how you're going to build the network, and then your databases, right? So we'll talk about underneath the services, but in nutshell, what I want to you to remember or understand is that cloud is nothing complex, right? You can feel cloud just by trying to have a feeling of your laptop, right? So your laptop have a compute, your laptop is having a storage, your laptop is having networking, and then on top of that, you need to have your databases, right? So those are our foundational services. So there are then some application service like CloudRun, so that is called CDN, your content delivery network, right? So if it is more of a streaming and those things, you want to cache your data. So you once you start developing advanced solutions, building advanced systems, you will realize that you if I want to get some request served from Colombo, I don't want to travel around the world to New York to serve that request. I should have a certain layer of caching, so that with that cache can serve, right? Example, if assume that now I know, like that at this moment we have this World Cup qualifiers, right? Sri Lanka versus Ireland, right? So that is streaming. You don't have to, when people are trying to access it via online, try to watch that match. You don't have to let that request travel through a world and to a physical server, right? Probably you can, what the physical server can do is it can start feeding that stream into a particular centralized place, which can cache it, right? Because it's the same request. If I send a request to this to watch the match, and you send it from your local from Peradeniya or where you are from, it will serve me very similar response, right? So it's the same thing, like hundred or thousands of people trying to retrieve, right? So why not we uh, instead of treating this 1,000 request as different request, maybe if we smartly identify that it's trying to retrieve the same data, then we can send it to another place which we call a CDN, content delivery network. From there we can start serving this traffic, right? So in this way, what we can do is we can very easily like reduce the time. We can reduce the latency. There will not be a lag, and there are so many other advantages as well, right? So then networking, so these are very key components, right? So there are, we will not go through much everything, but one other thing I want to do is monitoring, right? So cloud also have this capability of monitoring its services, right? So monitoring is, you can split it to multiple parts. One is your cost, right? So you have your the cloud environment, you have your services you are using in AWS. The first thing to know for you to monitor is your cost, right? So am I paying more? Am I within my free tier, right? Am I within my budget? What is the, what is the services which is billing me high, right? So those are the key questions, right? So that's important. Second one is, just like your on-premise, the hardware, and then on-premise, what do you call this, the softwares, right? The application servers, database servers, any other service, whatever in cloud is also going down. So there's nothing permanent about anything, right? Even AWS goes down, right? A couple of like 1 week back, AWS had the outage, right? And that outage was related to a particular region, and that has impact to so many big systems around the world, right? And there was outage around 4 hours, right? So so it's nothing that moving to AWS is like bulletproof, and you will uh, have your applications running uh, until end of the world, right? No, right? So AWS are again systems, and then these things will fail, right? And that's why even AWS saying, if your system is very critical, if it can't sustain an outage, then deploy it to multiple regions and have replicas enabled, right? So that in case of one of the region goes down, you can still serve your traffic from other region, right? So example, for airlines, for healthcare, and any other major critical systems, having deploy your application to multiple region is a must, because in case if there's a outage in one particular region, you will have a ripple effect, your application will come down, right? So those things you will have to monitor, right? Even in AWS is not AI, it's not artificial intelligence, right? So if I go and tell AWS I need a virtual machine with X amount of memory and Y amount of storage, it will give it me that. And then if I deploy application, and my application start consuming, and it will go run out of that memory and CPU, AWS will not do anything, right? I will still, AWS will not be intelligently decide, all right, I feel like you are going through you are consuming high amount of CPU memory, let me add more CPU memory. No, it will not, unless you configure to in such a way, right? So you have the option of, you don't do any automatic way of resource scaling, you just consume. And then if some day if the limits are met, your system will crash, and at that time you will have to get your alerts, right? Monitoring and then alerting, and then you will have to go and bring it up, doing the clearing and all sort of things. Otherwise, other option is, you say, okay, I want I define my capacity requirements, and I say, AWS, if you see my CPU is reaching 90%, you bring up a new server, and almost all the time maintain my CPU usage at 90%, at as much as CPUs, the resources as possible, right? So at that time, now AWS is little intelligent, it can add more the capacity, compute power, storage, based on what are the way I have configured, right? With the way I have defined, right? So those are the advantages, right? So that is what we call auto scaling, right? So in nutshell, I want to understand is, AWS is providing this AWS global infrastructure, regions, availability zone. You have your compute, you have your storage, you have your networking, you have your other things, and then you have your other deployment and management things. So on top of things, you can build your application. So AWS is providing all of this. Okay. So moving on, I'll quickly cover maybe each area, right? So compute. So compute is, so AWS, it's about your machine, right? So I want a machine to deploy a software, or the old, that is the old fashioned way, right? So I need a, so probably that translate into a virtual machine, right? You virtual machine is nothing but you put a lot of compute processors, and then on top of that you put a hypervisor, and then you introduce a virtualized software, and then you are able to provision VMs, we call virtual machines, right? So VMs you can have it based on your different operating systems, based on different processing power, based on different other criteria. So in AWS instance, one of the most famous or widely used instance is called EC2, right? And probably you have heard about Docker, right? So Docker is more of a containers, so it's going beyond your VMs. Probably you can like so because sometimes your application need different native environment, right? So then you can build a native environment, create a Docker image, and then ship it, right? So then someone, you can give the Docker image to someone else, and then someone will build that, and then it start up and running, right? Docker containers, right? So that uh, if that is again going one step, right? So those are a little bit of advanced things, but I just want you to know there are some things like that, right? We call it ECS, Elastic Container Services. So that is going beyond your EC2, right? And then there are different services like Elastic Beanstalk, EKS. So today we are going to cover some give a very high level overview of the Kubernetes. So the AWS have its own Kubernetes version, something called Elastic, the AWS EKS, Elastic Kubernetes Services, right? So those are the compute things, right? And these all are more of again processing power, CPU, memory driven. Still, as a developer, you will have to think through and understand what are my infrastructure requirements and give that to AWS, right? So then now the world is moving from these servers. So these are all servers, right? Servers to something called serverless. I'm even don't want to manage even this AWS servers, right? What if I just want to uh, uh, concentrate on my service, my logic? So assume that I'll give a very example. I'm a developer. I'm building a simple function where someone send me a Fahrenheit temperature from Fahrenheit. I'll do a conversion in Celsius, right? So then what happened, that service, if I want to expose, I will have to go into a cloud, and then I'll have to build VMs or EC2s, I'll have to deploy, and then I have to expose that to the end users, right? So assume that my one EC2 can manage 100 concurrent requests, but if I get 200, I'll have to add another EC2 instance, right? If I have get 500, I have to add more EC2 instance, get more compute power, more storage to serve this, right? So again, I not only about my small method of the temperature conversion, I'm focusing on the infrastructure as well, right? So AWS has introduced something called serverless, where as a developer, I'm only going to focus on that particular code, that method, right? That temperature conversion. And then I go and deploy to Lambda or serverless, and then AWS take care of all the infrastructure. So so I'm just going to pay AWS for the request count. So if I get 10 requests, I'll pay for 10 requests. If I get millions of requests, I don't have to worry how I'm going to build a infrastructure to uh, support millions of requests, or how I'm going to scale. That AWS will take care, right? I'm just simply going to focus on my code, how to make it more of a to support concurrency and other things, but I'm not going to worry about infrastructure, right? So that is the beauty of serverless. So the serverless are again part of compute. So compute is more of your instances, your containers, and then serverless, right? Without servers, right? So those are the key themes when it comes to compute. So then moving on, you have your storage. So storage is nothing but our laptop drive, right? You have your C drive, you have your D drive, you have your E drive, you have your the pen drives, right? And then you can have your extended uh, hardware, right? All those, right? So in AWS also they have we have different storage, different services. So what they have done is they have divided storage into multiple parts, right? Mainly fundamentally two parts. One is your objects, right? So example, if I ask you, okay, tell me, right, storage. How are you going to use storage? You will think through and tell me, Indika, okay, I'll save objects into my storage. Object is nothing but images and different kind of like the files, right? Then you will say, I want more for block storage, right? I want the blocks, right? So it's not objects, I want to have block streams, right? So fundamentally storage can get in divided into a couple of parts. One is the objects and blocks, right? So here I will first focus on the blocks. So the objects, so or AWS we call objects as S3, right? So S3 you can store your objects, right? Your images, files, and all those things, right? But then AWS, because it's money, your storage is money. There are cheaper version as well, right? So assume that I have I can have my S3, right? The storage, and then based on if I'm not going to access my objects uh, for regularly, assume that I'm going to access my data once a year, so then I can go into more cheap options, right? I'm going to use access my data once a month, right? Then I can go for one cheap options. Probably I don't know I'm going to access once a month or once a year, right? So then I can go for more intelligent options, right? So based on that retrieval, the cost is vary, right? So if I'm going to access my data once a year, then I can go for more cheap options, right? But I want data access in a very regular, I can go with a little bit of expensive options, right? And then this is more for object storage. Then there are EBS, Elastic Block Storage, which is providing the block related storage, right? So you don't have to really get to know these names and those concepts, but you have to understand that these are very simple concepts, right? So I'm going to store my data, and then based on whether I need to retrieve this data regularly, I'm going to use the different storage classes, right? So we can have S3 intelligent tiering, S3 uh, standard intelligent tiering, S3 on glacier, right? Different things. So at this moment, you don't have to really get confused. But what you have to understand is based on different kind of criteria, we can have different storages, right? So that is the one key thing part of storage. So then networking, right? So AWS, you will have to create your own network, right? So there's something called VPS, virtual private network. It will have your subnets, it will have your routers, it will have your internet gateways, your custom gateways, VPNs, NAT gateways. So those are probably new things for you, right? But one thing I want to tell you is that if you are into cloud, you will have to know about your networking, right? Without forgetting about network, you can't get into a cloud, right? So if you're a person that thought that I don't have to fully focus on network, but I'll jump into cloud, I will getting into DevOps, that is not going to work. You had to have some decent knowledge of networking, right? So that is the summary or the message I want to give you part of this. So next one is database. So AWS comes with a different type of databases. So example, there are relational databases, there are key value databases, there are document type databases, there are graph databases, in-memory databases, search databases. So I remember that in my time at Peradeniya, like database is again an interesting subject and a boring subject. Interesting subject because when I'm doing my practicals using MySQL database, if I remember correctly, then it was very good. So I like creating a database, creating tables, inserting data, deleting data, editing data, creating a PHP based application, and sending data, retrieving. So that those are good times, right? Practical was good. But when I have to learn about the database normalizations, the table normalizations, especially when it comes to relational databases, or the different hashing, tree structures, graph, and all those things, those are a little boring, right? My mind, I was questioning, are we ever going to use these things, right? But probably I don't know whether you have completed your database subject. Probably yes, but whatever you learn, it will you will start using them, right? When you start being a developer or DevOps engineer. So everything matters, right? You will understand why sometimes the tree is good, one, right? One where to use a graph database. So all those theories you have learned will come into play, right? So that's again just I want to tell you that uh, everything will come into play, right? When you start getting into industry and start developing systems for actual needs, right? So here in AWS, again, I'll repeat, we have relational databases. We call Amazon Aurora or RDS, key value database like DynamoDB, DocumentDB, like again, so I think this is a typo. So there are again, like there are a lot of uh, the document type DBs as well, and then graph DBs, in memory DBs like Elastic Cache or Redis, and there are Elastic Search and all, again ELK stack related search kind of databases. So then what this mean is that knowing the fundamentals of database is important for you, and plus you had to understand the theories behind databases. Just because you are going to cloud doesn't mean that you can forget about all those theories related to your database subject, and then start jumping into cloud and then start working. So that will not happen, right? So then other thing, so then what you can ask, okay, again I might have a MySQL, and then I will have to worry about the infrastructure to support MySQL. Uh, for some services, yes, but then AWS comes with the AWS RDS, right? RDS is fully managed database service. You have to simply focus of your database, not about the infrastructure. Infrastructure, which is hosting your uh, the database, right? So the Amazon AWS will take care of that. You just have to worry about the part related to your database. So that's why RDS is very important, and that's why RDS is very powerful, right? So that's one of the difference why RDS is important, right? So again, in nutshell, we will have relational databases. It can be Aurora or RDS. RDS is Amazon managed. Then key value, DynamoDB. You can have your document DB. You can have Neptune, your graph databases, right? This is very good, when you have like, uh, like sophisticated data related to real time, the gaming, social, social what do you call social media related applications in memory, again like likewise, right? So very high level, remember that AWS comes with different type of databases. So then everything in AWS will come together like this, right? So now this is your AWS, right? So here you will have your availability zone, right? I told you AWS global infrastructure. AWS global infrastructure is hosted in regions, and a single region can have multiple availability zones, right? So that's why probably this particular application we have replicated in different availability zone. So this can be in one region and this can be in another region, right? So that's within availability zone. You will within AWS we can create our what you call VPC, right? We call this is a VPC, right? Virtual private network, right? So everything within all those services are within inside that virtual private network, right? So here you can see now your compute power. If you see EC2 is there, Then you can see your database, RDS or DynamoDBs, all those things are there. So the storage S3 is there, right? So the collection of these things, you can create a systems, right? And then cloud front, which is a kind of the CDN is there. So I'm not going, I don't want you to remember those things. I don't want to make you complicated, but what I want you to do is remember is that these are the services. So AWS is nothing isolated thing, nothing magical. It is the same traditional on-premise data center. Now it's in cloud, and it's a more rapid way of getting these services, right? So that's a AWS in very quickly. Finally, what we're going to focus is there's something called AWS shared responsibility model, right? So what this model is that just because you're going to cloud doesn't mean that you don't have a responsibility, right? So AWS will have its own responsibility, and as customers we will have to have our own responsibility, right? So what, so that is a very important thing you need to remember, right? So before you go and create any software systems in AWS, you will have to understand that there's a boundary that AWS is going to control, and the outside that it's your control, right? So what is within AWS? So AWS will control its regions, right? Whatever within the region, AWS manage. AWS is control its availability zone. AWS will look at its edge location. So these are all controlled by AWS. So AWS is on its compute, storage, databases, network. All those key things are owned by AWS, managed by AWS. And what are the customers' responsibility? Example, or if all the client data you're going to put it into AWS, that data encryption, authentication, authorization, you have to use AWS and you have to do it. AWS, just because you put data in AWS and tomorrow someone hack can get that data out, you can't go and blame AWS, right? So AWS is providing infrastructure, but you will have to build your authentication, authorization, and encryption mechanisms, right? And all those your server side, network side, protection, everything you will have to do, right? All your operating systems, like example, AWS gives you a VM, but you are selecting Linux, and then Linux patching and all, you will have to take care of that, right? If you are, and all of these related to that, the access management, the customer data, everything is your responsibility, right? So you, this is a I don't want you to know in everything, like get a full understanding, get a feel of everything, but I want you to know that AWS, there's something called what AWS is responsible for, and then there's something called what customer is responsible for, and we call this more of the AWS shared responsibility model, right? So again, if I go back very quickly, if I go through, so AWS is nothing but your global infrastructure, regions, availability zones, edge locations. Within availability zones, you will have your compute, storage, networking, databases, and other services, right? So those are the key things you have to remember. And then when it comes to compute, you will have your instances, EC2s, you have your containers, your Dockers, ECS, you have your serverless, which is your Lambda, and then uh, you have your storage. Here I'm only discussing about S3, but you will have your the EBS, elastic block storage as well. S3 also, again, based on the type, the need, you will have your different classes of storage. Then you have your different network components. You have to build your own network in AWS, and you will have to secure your own network. So that is your responsibility. AWS will provide the services. Then you have your different databases. You have your relational databases like Aurora. Then you have your AWS manage, which is AWS is managing. You just have to focus on using the the database services. Then you will have your key value databases like DynamoDB, DocumentDB, uh, the Amazon Neptune DB, Elastic Cache, Redis. These are in-memory databases, Elastic Search databases. So wide variation of databases based on the requirement, right? So it's not that we go and going to use everything, but based on the requirement, we're going to select what to do, what to use. right? And then we will build some architecture like this, where traffic comes in, it will go to edge location. From there, it will come to a particular cloud front, which is our CDN. From there, we can do a load balancing, which AWS does. It can send the traffic to different availability zone. From availability zone, we will have your EC2s, and then EC2s will go and access our databases, and then objects will be taken from S3. So this is kind of like a very simple AWS setup, right? So everything will be within a virtual VPC, virtual private network, right? And then finally, what you have to remember is that just because in AWS, it's not that uh, entire responsibility with AWS, right? So AWS will responsible for regions, availability zones, its compute, storage, database, and network. On top of this data we are using, the customer data, it's our responsibility. The platform application, the access management, our responsibility. Operating system, network, firewall configuration, our responsibility. Client-side data, encryption, authentication, our responsibility. Server-side encryption, our responsibility. Network traffic protection, all those things, again, our responsibility, right? So there's a lot of responsibility for us as well, right? So that's it, right? And very quickly, that's high level what I want to cover. So I know, like it can sound like a lot of theories, lot of new words. So don't worry, right? So this is a very introduction. With the practicals you're going to work, you will understand these concepts. But these concepts are very important, right? And after this course, like in our WhatsApp channel, we will share you some documents, some the materials where you can spend more time. You can't learn AWS within 30 minutes, 1 hour course, or 1 hour session. But you need to have this basic knowledge. This will help you to build your foundation. With that, you can start uh, going through and uh, start having more understanding of AWS and how to use it, right? So with this, I'll close this session. I'll not ask if you have any questions. Probably, you can send it to our WhatsApp channel. Then we can start answering. So Kapila, over to you, right? Maybe you can start your Kubernetes session.
Thanks, Indika. Sure. Okay. So I assume you don't have any questions because since you guys are silent. And so basically, this is what we discussed last time, right? So the deployment architecture that we're going to implement as a part of this case study. So as you can see, even like as we discussed last time, so we are going to create a Kubernetes cluster with 3 nodes, and we will have a single master and then 2 worker nodes, right? So this is the reason actually this Kubernetes basically important here. So now we'll move to today's session. Basically, we'll try to give you kind of like high level idea on this Kubernetes, and we'll discuss the benefits and all that. So basically, yeah, let's look at what is yeah. So let's look at what is Kubernetes, right? So actually, I really appreciate if you can it can be like as they always say, like it should be need to be a kind of a um, interactive session. So I really like you to if you can speak, and I really appreciate, because it gives motivation to me, as well as also I can I can understand whether you understood these things or not. Really appreciate if you can unmute yourself, and if you can basically talk, right? So if you have any doubts, just ask me. So I will try to explain as much as I can, and then if not, I will basically find the materials and all that I will share later. So basically, yes, starting today's one introduction to Kubernetes. So first of all, like let's look at what is Kubernetes, right? So Kubernetes is a, as you know, open source uh, container orchestration system. So right. So and also you can actually using Kubernetes, you can automate the deployment part, right? So the deployment, and as well as you can actually uh, configure scale, like you can scale your environment, scale up and scale down based on your needs, and also you can manage entire basically entire like system, entire what you call environment, right, using Kubernetes. So and so these are the things actually we can get benefited from Kubernetes. So as you can see, like service discovery and load balancing. So in Kubernetes, actually, when you deploy in a pod, so we will discuss these terms later. So pods and all that. But when you deploy a pod, Kubernetes actually create and assign IP addresses and as well as DNS name. So each pod and services will have will get unique DNS name, and from that actually you can configure implement load balancing. Load balancing, basically you can balance your load to different nodes based on your configurations, right? That is load balancing. So Kubernetes actually using Kubernetes you can implement load balancing and as well as service discovery. So service discovery can be achieved since we have DNS configured like in cluster. So we have Kubernetes assign DNS names and IP addresses, so we can configure. We can actually get the support service discovery and load balancing, as well as storage orchestration. So basically, like in every case, so we need storage, right? So I mean, we have to deal with the storage, like because you need to like store data in your hard disk, right? So basically, like Kubernetes, using Kubernetes, you can map your local storage like public cloud providers or anything, whatever is, the storage you can map to your entire what you call environment, in an entire you know application environment. So we will discuss this in detail. So, but and also like automated rollouts and rollbacks. So basically, let's say, I mean, if you want to like automate your deploy your changes, right, and also maybe your configuration changes into your environment, maybe production or whatever, you can automate that, as well as let's see if something goes wrong, so you can actually configure to revert back and go back to the previous versions, right? So these things can be actually configured in Kubernetes, and also you can actually what you call configure the what you call CPU and memory. How much CPU you need to like basically resource assigning resources for your ports, the processors, right? So you can configure how much CPU and how much memory you need to assign to particular process, right? You can configure that, and as well as self-healing. Self-healing, like for example, let's say if some process or a container uh, you know it might fail, but Kubernetes actually can try to like restart those containers if it is failing, and also you can configure to replace those containers if it is still failing. You can basically kill the entire thing. So you can configure all these things in Kubernetes, as well as secret and configuration management. Secret are basically nothing but less sensitive data. For example, password and all things you can configure in the uh, configure and manage in Kubernetes, and as well as configurations as well. And this auto scaling part, horizontal auto scaling. For example, let's say you have process, and then if you want to like increase or decrease the number of processes based on the load, you can actually configure that in Kubernetes. So Kubernetes will basically take care of basically auto scaling part. Like if if you need more, like if you want to like process more data, so you can simply increase your port counts, the process count, right, to response to the load. Those are the kind of like set of the benefits we can actually we can get from Kubernetes. And any questions before I move to next slide? If you want to describe anything here in detail more. Okay, so let's look at components. So as you can see here in this picture, like you can see the grayed area. This is a cluster, right? So this is Kubernetes cluster, and also you can see the blue line, right? So this area basically we call control plane, right? And also there are set of boxes here, right? So as you can see, those are called nodes, right? In a cluster, actually, in a Kubernetes cluster, so we have control plane plus nodes. Okay, as you can see inside control plane, you can see there are several components, right? So like we will discuss this in detail. These are basically the components which are like related to manage the entire cluster, and this are called nodes. In inside a node, actually you can see again several components right here. Two components we have, like they're showing here. So this is basically the like key components that you can find in a Kubernetes cluster. And so as you can see here, like there is something called API server, cloud control manager and control manager, and also etcd, kubelet, proxies, scheduler, yeah, so many things. And so I will move on, and I will describe all these components in detail, right? So as I said, like control plane, basically this one is the core like core area, the core components that can that manage the entire cluster. Okay, and inside that, so you can find several components. First one is API server, Hoop API server. It's actually, as you can see, it's a kind of a like the main entry point, main basically the service running inside the cluster. Okay, so basically this API server interacts with other components as well. Here you can see it's CD, control manager, scheduler, Hoop admin, and all these components will interact with API server. So all the communication actually will go through API server only, right? Let's say if you want to like, let's say if controller manager wants to talk to etcd, it has to go through API server, right? API is a kind of like middleman, right? So I mean, even like if you want to like execute some command, we'll talk to API server first, and then API server will take care of like basically will identify and authenticate the request, and all that will redirect to relevant component. Okay, API is the kind of entry point, and etcd is a database in the cluster. Like let's say, I mean, so you want to like store some data, right? Maybe details of pod status and all the information relevant to the cluster will be stored in etcd. Etcd is a database, right? And also we have something called scheduler. Schedule actually what scheduler does is like I mean, it looks for newly created the pods. When you create a pod, I will explain what is pod in next slide. So when you create a pod, for now just assume pod is a process, right? When you create a process or a pod, it will like basically I mean, it has to be running in a like maybe machine or somewhere, no? So basically schedule can actually decide, like when you execute a command to create a pod, it will basically search for available nodes, and then it will, based on the resources and all that capacities, it will redirect to the relevant pod to be run configured in a net node, predefined node, like based on the resources available, right? And also, like, it's look basically the way the pod is running or not. So it's a scheduler. And we have something called controller manager. And controller, I mean, in here actually in Kubernetes there are a set of controllers, right? So you can see here, node controller and job controllers, endpoints. There is, I think, so, I mean, there are a lot of controllers. So basically, control manager is the one who actually manage all these controllers. Like in Kubernetes, control is like a voucher. For example, let's say, so you are in a room and you have AC. Your current temperature is 32 Celsius, and you have the remote, and then you want to decrease the what you call temperature. You want to basically the reduce the temperature to 30 Celsius, right? So let's say when you press that remote and you send a signal to AC, right? So then the AC machine will decide to, okay, understand, okay, current temperature is 32. Now you want to reduce to 30, and then it will start to process, like it will take some actions to reduce your temperature, right? So that is what basically control. It looks for the changes, and then right, so I mean, you have, like, decided state, and then the current status will basically do the processing to go to decided state from the current state. That is the basically the what do you call, the benefits of, like, the basically the actions, like the purpose of controller in Kubernetes. Okay. So, we discuss about the control plane components. Now we are going to discuss node components, right? So I'm going back to the image here. See, we discussed this, right? We have two major parts, control plane and also node, right? So we discuss the components which are inside in control plane, right? Okay, remember? So API server, etcd, scheduler, control manager, all these are inside control plane. Okay, now we are moving to node component. Basically, components running on each node. Okay, and kubelet. Basically, every node will have a kubelet. So basically, kubelet is a kind of agent. Okay, runs on each node, and it will basically communicate with API server. And also we have something called proxy, and I hope you remember. So I said, like, every pods, right? Every node will have a IP address and DNS names, right? So basically, kube proxy is responsible to, like, basically handle network. It attacks as a network proxy. So it will, like, allow you to, like, communicate with other nodes, and based on the rules that you're defining. And also we have something called container runtime, right? So every node will have container runtime as well. And for example, let's say if you want to like, you have some application, right? So you have developed an application in Java or something, right? It's a Java. Now you want to deploy that into Kubernetes, right? So when you, like, try to deploy an application in Kubernetes environment, it will basically deploy into node, right? Worker node. It won't, like, deploy in control plane, because control plane is the one who manage entire cluster, right? Entire your Kubernetes cluster. But all the services, the whatever that you deploy in your cluster will run on nodes, worker nodes, right? So to run actually your application, you need the environment, right? You need the container runtime. Like for example, so we'll have, I mean, in this case we are going to use Docker, right? And so when you like deploy an application, it will I mean, each node will have a container runtime, and then you can actually configure I mean, your application on this node using container runtime. And these are the concepts that we're going to talk about. I mean, do you have any questions before moving to next section, Kubernetes concepts? Okay, right. So yes, first one is pod, right? We discussed, I mean, talk about pod, right, many times before. Actually, as I said, pod is the process, right? The smallest, basically, object in Kubernetes. It's a process, right? So, and I mean, let's say for example, you run your Java application in Kubernetes, so it will be a pod. It will run as a pod, right? And then it will basically, pod contain one or more containers, right? Like anything you can have. I mean, in this case, we are going to use Docker, and also actually pods can contain shared networking and storage resources. Basically, to access. I mean, let's say if you are, application running in a pod, you have to you should be able to access those the services, right? To access those things, so you need the network, and also the pod might use some storage, might want to actually store some data in your hard disk or somewhere. So pod actually will have these things like network and storage, and also as you can see, uh, there is something called life cycle based on the status, right? As soon as you create a pod in cluster, it will move to pending state, and then once pod actually deployed successfully and it started created successfully, and it started into basically move into a running state, and once you have like terminated all these the pod, it will move to succeed, and then if your pod is, I mean, failing, it will move to failed state. Based on these status, actually you can understand, right? So if your pod is running, then okay, you are fine, because you know your pod is working. But if it is failing, then something wrong with the pod, then you have to like go to your cluster, and you can actually check log files, right? Relevant log file in the pod, and you can understand why this is failing, and based on that you can provide a fix. And so node, again, we discussed, right, a couple of times we discuss this node thing. So it's a node is nothing but it's a kind of like a virtual machine, can be, right? Or a physical machine where you plug into your Kubernetes cluster. Okay, so and as you can see, like single node will have multiple, can have actually multiple ports, right? Um, and as you can see here, and also we have something called yeah, before that actually this the name, every node will have actually a unique name, because you need to identify, right? You need to basically identify each node in the cluster uniquely, and then every node will have unique identifier. Um, and also we have something called node controller, right? So basically, node controller is responsible to manage your node, right? And also as you can see, there are several roles in again in nodes, assigning CSRE block to node when it is registered, and also monitoring node health. So these are the basically responsibilities of node controller. And uh, and yes, control, I think I mean, discussed this controller before. Like in Kubernetes, we have several controllers actually. Like for example, replica set and deployment, stateful, daemon sets, cron job. There are a lot actually. You can actually go to Google and you can find all these controllers. Uh, Service. Services again, another important aspect. Like for example, let's say if you have a pod, and then you want to like talk to your pod, right? So I told you, right, so every pod will have unique IP addresses and DNS name. So basically service can will enable you to basically talk, enable you to provide this network access. Like it's a service is nothing but it's a network access, right? So if you want to talk to a particular port, you have to like configure a service to the your port, and then it will you can actually configure your service, the ports and everything. And like you can have a kind of a mapping, what is your public port and the internal port. All this can be configured in service. Service is basically provide facility to access your port, okay, through your network. And these are the basically common types, like cluster, cluster IP, node port, load balance, right? So cluster IP is a default one. So basically, if you're going with cluster IP, then your what you call service only accessible within your cluster, Kubernetes cluster. But if you go with node port, actually you can access externally, like from outside outside the cluster. And yeah, likewise, there are several service types in Kubernetes. Okay, so namespaces. Again, namespaces are basically kind of a like virtual group. For example, let's say you have a cluster, and in Kubernetes, you can create virtual subclusters using namespace. For example, um, uh, let's say you have two environment. Okay, you have development environment as well as you have test environment. Okay, and then but you have only single cluster. Okay, but you will have same service. Like for example, let's say you have payment service. So you have payment service in dev environment as well as test environment. Possible, right? Using namespaces, you can create a virtual cluster inside your main cluster. Let's say called dev cluster. Then you can deploy your payment service in dev cluster namespace. And if you want to like deploy same service, payment service in test different cluster, different environment, same cluster with the namespace, you can create test cluster namespace, and inside that actually you can deploy your uh, payment service, right? So single Kubernetes cluster, but you can have two different subclusters, virtual subclusters using namespaces. Okay, I hope I explain and you understood. If it is not clear, please ask. Right. So there are several actually 4 initial namespaces. By default, you have something called default, group system, public, node, release, and group system. Basically, it's a default. What do you call? The objects created by Kubernetes systems will be stored like here system. And let's say you can create multiple namespaces in your cluster. And when you deploy a pod, if you haven't defined any namespaces, it will be deployed in under default namespace. But if you had define your the namespace once you are created, when you deploy in a pod, you have to define your namespaces, which namespaces that you want to use. So based on that, it will deploy. If you're not defined, it will be in default. So another aspect is storage. So obviously, right? So you need to you should have like your you should be able to like map your storage into cluster, right? Kubernetes cluster. There are several concepts under storage. Volume is basically the directory, right? So your physical storage volume is a directory. You can actually configure using these things. You can actually map the storage into your cluster. And there are several types, like as you can see, config map, secret, and mtdr. Those are basically the type of volumes you can find in Kubernetes. And persistent volumes are basically uh, like it's a kind of like way to map your volumes to storage, Kubernetes cluster. and and uh, and also uh, it manage actually the life cycle managed by the Kubernetes. And you can actually configure that volume to provision dynamically. And as well as this one, the claim is what is basically is a request. So you have actually configure your volumes and persistent volume, and now you won't actually use that into your in your application. So in that case, you need to claim. Okay, so defining your size and access mode. Basically, you need to send a request to your persistent volume. Okay, I need out of 100 MB, I need 5 MB for this particular application. Likewise, you have to claim, right? You have to send a request to claim storage for your application, right? In that case, you can actually define whether you need read write access, both, or read access or write access. So based on defining all these things, you can actually claim for a volume, like persistent volume. And uh, so basically storage class is again like Kubernetes object. And also like when you define the claim, you have to, as I said, you need to define size, access mode, and storage class for the volume, right? There are several actually storage classes you can find in Kubernetes. Yeah, okay. So I had covered actually basic concepts. And if you search on Google, you can find many. But this is just to like start tune Kubernetes, and then I just covered with, components and the concepts in very high level. So up to now, do you have any questions? Do you want me to explain anything? Really appreciate if you can actually unmute yourself and you can speak, because it's really right good, right? Then I can understand whether you understood or not. And then nothing to worry. This is, as I said, like this won't impact your final uh, research sheet or anything. Any questions, team, please? පොඩ්ඩක්වත් තේරුන්නේ නැත්නම් ඒත් කියන්නේ. කුත්ම තේරුන්නේ නැද්ද? At least you got some idea. Okay. Okay. Right. So moving on, I have just basically identify uh, two scenarios just to give kind of like idea how this basically the cluster and these actions are working. And so just assume you have sorry This is your cluster, right? You have a control plane, and then you have APIs, and then HCD, right? We know that HCD. What is HCD? What is HCD? What is HCD? Please, can someone tell me, explain, please? Shall I pick? Oh, can someone please unmute and Karudunada Tamanne, got the HCD again. I really want you to interact, right? I mean, otherwise it's boring, eh? Okay, as usual. Okay, HCD is a
Key
database,
value
right?
store.
Super. Yeah. Who said that?
It's me, sir.
HCD, right? Tarindu neda?
Yes, sir.
Cool. Yes, it's a database. Yes, key value pair, like where you store your data, right? As a key value pair. Thank you so much, Tarindu. So HCD is a database, right? So an API server is where you, like I told you, na, it's an entry point, right? So to the cluster. Now I'm trying to actually list pods, right? So let's say this is my control plane now. So I have several worker nodes in my cluster. So I'm trying to actually list down the pods. You remember, right? What is pod? Pod is the process running on maybe running in a node, right? There can be several, pods in a node. Now you have to like memorize. You have to like what we discussed. You have to just memorize, right? Now I'm trying to actually list down the pods in our cluster, right? Okay. This is the command, right? kubectl is basically the command line program to execute commands to cluster. You need kubectl. Kubectl is a small command line program. You need to basically give commands to kubectl, then it will execute the command and will give the output, right? So what I'm going to do, so I'm going to list down pods, right? So basically list down all the pods running in my cluster. So here, to list down pods, this is the command that you need to give, get pods, right? I'm trying to list down, right? I need to get pods. This is the command you need to give if you want to list down pods, right? This part -n, then we have something dev1 elk. Okay, this is how you define your namespace, -n, right? -n. Okay, this is my namespace. I have created namespace called dev1 elk, right? This is my namespace. This is how you define your namespace. If you I mean, basically like you can give any commands here. If you want like run these commands for this namespace, this is how you define your namespace, right? In simple terms. So I'm going to get all pods running in this particular namespace, right? dev1 elk, that is my namespace. Okay, when I type this and hit enter, it will go to API server. Okay, you remember, right? API is the one who actually is an entry point, right? All these commands, whatever you execute in using kubectl, it will go to API server first, and then the API server, it tries to basically authenticate and validate the request. So it whether, I mean, you have privilege to execute this command, and you have actually your command, you have entered your command in a proper way, like accepted way. It will validate. It can validate. If there's any issues, it will basically say, okay, this command is wrong, or maybe you don't have privileges or something, right? Based on the the results, it will display. But let's assume you have proper authentication and then your command is valid. Then it will go to HCD because you are trying to get details of ports, right? Okay. In a cluster, where do you store all this information, the relevant configurations and everything? HCD, right? It's a database, right? So in HCD, you can basically Kubernetes will store all the configuration detail in HCD, right? In API server, no, it's okay. This guy is requesting all the ports, the details of port, then it will, okay. This is the HCD is the one who actually store all this information. HCD. And HCD actually, return the required data to API server, and then API server actually will return to the results to your user, right? In your command line. In basic format, this is how it display. You can see there are several. There are 5 columns, right? Name, ready, status, restarts, and then age. Okay. So see, we try to like get all the ports running in this dev1 lk namespace. I can see 3 ports are running. Okay, and this status is running state. You remember, right? I explain now. In these are ports actually, right? Pod have life cycle, and then there are like several status, right? Running, what you call fail, okay, succeed, right? So those are the, but this there are 3 pods. All 3 pods are running, no restarts. So once we are created, if there's any, there might be like scenarios where your pod might fail, right? I told you, self healing, like it tried to recreate the pod, or it tries to actually the Kubernetes will try to redeploy, recreate the pod and restart the pod. And if there's any restarts, so you can see, okay, how many restarts happen after you create the pod. Okay, but this case, no restart. That means these 3 pods are running without any issues. And then age, how many minutes, basically aging. So you have created these what you call 3 pods 29 minutes ago. Okay, that is aging, right? Let's say, so you didn't define this namespace. You simply execute kubectl get pods. That's all. You define. You didn't mention this namespace part. Then what will happen? Then what will happen? I explain this. If you don't define namespace, then it will take it as default, right? You remember? Default, right? So we have something called default namespace. Then it will try to retrieve all the posts under, running on inside default namespace. Simple. Okay. Right. So this is how you this is what happen actually when you execute a command, simple commands like get ports, and then it will, as I said, it will try to like communicate with the API server, and then API server will send request to HCD, and then HCD will send the response to the API server with all the information, and until API server will again send back all the results to user command line. Okay. The second scenario is again we have we are trying to actually create new port, right? As you can see, this is our control plane. Then we have 2 worker nodes, right? And in control plane we have API server, scheduler, and our HCD database. And then so this is our what do you call worker node, and each worker node will have a kubelet and proxy. Not proxy, I think container. Yeah. container runtime. I don't know how to write this. Yeah. Okay. And then we have container runtime. So let's say now I'm going to create new pod, right? Okay. This is how you this is the command actually you need to like execute to create a pod. Okay. And again, you are sending your command to kubectl. Told kubectl is the command line from command line application to execute. I mean to give commands to your cluster, and then you have run command. Kibana is basically a name that you are going to assign to this particular new pod, right? You are going to run Kibana, and here actually you can define your image. Okay, so I mean, I hope you like have some idea about this image, right? I mean, image is like it's like this basically. You have we discussed now, so we are using Docker, right? So Docker is our container, and like image is nothing but is a again I mean predefined application, predefined environment. So in that maybe you have like create your own image with the predefined configurations. So you can actually like configure your application with predefined configuration, and you can host shared in shared location. So right, for example, maybe I hope you have like heard about Docker Hub, right? Where you configure, you create your application, and you convert that into image with the predefined set of configurations. So here we are trying to actually we have created the image called Kibana. We are trying to actually download that image and trying to actually configure, right? Run our this image as a pod in our cluster. When you execute this command, it will I told you, right? So it will first go to API server, okay, and then it will validate, I mean, authenticate and validate the request, and after that, it checks with HCD. Why? It checks whether we have, I mean, running any pod with this particular name, Kibana. Okay. So because I told you, right? So name has to be unique, right? I mean, if there's any current, I mean, already running up, I mean, pods, it will say, okay, this is already running. And also if there's any, I mean, if there's any what do you call no Kibana, I mean, no any pods running with this particular name, and then it will register, it will enter, right? Enter record saying that okay, now we are trying to add new pod called Kibana into our cluster. Okay, this guy will actually add some record in their status in the database. The status might be initialized. I mean, it's not running now. Simply it add a record. Okay, now we are trying to add a new pod into our cluster, and then it will send back the response to API server. Based on that, actually, so this scheduler, okay, you remember, right? We have something called kube scheduler. Kube scheduler is the one who actually looks for this what do you call monitor this API server and checks whether there's a new pod. If there's a, I mean, if you get a new trying to create a new pod, it will simply what it does, it will get the data and then it will select which nodes that you can actually use to deploy this particular pod based on the availability and based on the resource availability and all that, the rules that you are defining in cluster. Based on that, it will pick, okay, this pod needs to be deployed in this particular node. Okay, kube schedule is the one who actually decide that. And let's say you send a what you call request, and then HCD, okay, you added an entry saying that okay, this particular image will be added, pod will be added to this cluster, and then after that it will group scheduler decided to okay, we got a new pod to create. So okay, then it's selecting node. You need to deploy this into node 1 based on the availability, resource availability, and then API server. So got the message from the scheduler to create that particular pod in node 1. Then it will send, it will communicate to node 1 through kubelet, and then saying that okay, you need to create new pod in your node, and then kubelet will actually try to create, try to download this image, and then it will configure. It will start like create the pod in worker node 1, and then after successfully created, it will send to message to API server, and then so API server again goes to HCD and say that okay, we have created this particular pod called Kibana, and it's running. So then HCD actually will change their record to okay, we have created this particular pod in our cluster, and it's running. And then again API server will send back to the command prompt saying that this pod is created in your cluster. Okay, this is the basically high level the flow that will happen like when you try to create a pod in your cluster. Again, so you define your what you call name pod, and then image. It will go to API server. API server actually will update HCD saying that okay, if there are any existing pods or not. Otherwise, you need to enter at the entry saying that this particular pod going to be created, and then it will scheduler will actually look for like if there's any new schedule new post that will be created, then it will simply based on the resource availability decide which need to be which node needs to be used, and then based on the message that we got from the scheduler, API server will decide, will pick the node, and then we'll communicate to kubelet to relevant kubelet to deploy the particular what you call pod into their node. And once it is successfully created the pod, then it will go back to API server. Kubelet will notify API server to okay, we have created this particular pod, and then it will API server will update HCD okay, saying that we have created this pod, and same time it will send back to message to user saying that we have created this particular pod. This is how it works. Okay, any questions? This is just to give you kind of a like high level idea how these components interacts with each other, and okay, right. I hope you got some idea, high level idea of this Kubernetes and the components, services, and all these basic concepts. So we are expecting you to basically set up 3-node Kubernetes cluster in your AWS environment. First, you need like register, create an AWS account, and then you need to try to create 3-node cluster, single master, 2 worker nodes. Okay, and so and also we are expecting you to like complete this exercise within this week, and then we'll pick randomly to you should be able to you should be ready to actually present that. If you ask, we'll pick few people randomly next week, and then we'll ask you to basically demonstrate your environment. You should be like simply create showcase what you have done during this week. So that is the exercise that we expecting you to complete during this week. Hope This is clear. Any questions? Anything you want to clarify?
So in here, so let me. Okay. So now we are going to create a EC2 instance, and we are going to deploy WordPress into this EC2 server, and we will create a MySQL database. So rather than install MySQL into a EC2 server, we thought to create a MySQL database as a service from AWS. So you know that in the AWS, it's giving services as well. So so in here, I can demonstrate how we can obtain the how we can obtain MySQL as a service and what are the benefits. So you will see that as well. And each EC2 instance or the database, there will be a security group. So the security group is like we can control the request, or we can control scripts, the request which are going from to other components, or receiving a request from other components to the particular service or the instance. And there will be end users. Those are accessing the WordPress application or the EC2 instance. So they will they will access the EC2 instance via HTTP or HTTPS. So this is the high level design what we are trying to create now. So okay, so let me open the. So I hope you all are having access to. I mean, you have all created your own account to in AWS. So just yes, last time we demonstrate a pipeline code commit. So if you try that by yourself, then you will have a basic idea how the bucket things work. So in here, what we are trying to do here. So first, we will create a security groups. So we need two security groups. For one is for EC2 instance and one for our database. So let me create a security group. In here, we can mention security ST4 instance. WordPress. So you can give any kind of name, but give a meaningful name so you will understand what is this group about. We will. So this is the virtual private, I mean VPC. So I'm using a default VPC. I'm not going to create any VPC at the moment. So I'm not going to create any rules. So I'll create the two security group. After that, I'll create the rules. So one is done. Now going back to security groups and creating one more. Yes. Okay. So I'm using the same VPC. I mean the default VPC. Okay. Okay, now I have created two security groups. So let me show it to you. Okay, in here, so this is a default one. It's created by default. So just ignore that one. So we have created WordPress DB. This is for the DB instance, and this is for the EC2 instance. Now I'm going to create the rules, security rules. So I'm first create the rules on instance security group. So what we need, so if we move back to the presentation or the design, so in here end users should access. So we have given HTTP or HTTPS. So we have given two methods to access this particular instance. So then we need to edit the inbound rules. So inbound rules, we need to add rules. So one is for HTTP. So in here we can mention what is the source. I mean, from where we can get this one. So so this is for the website, and we need to access users from anywhere. So I'm giving anywhere. In here you can give any description to uniquely identify. This is optional one. So if you give a description, then you can clearly understand what is this rule about. So site HTTP. Okay, and we need to add HTTPS, same as HTTP. So from anywhere. Okay, and again, now we need to do configuration. I mean, we need to install WordPress. Then we need to HHS the. I mean, we need to connect from our putty or our terminal to this particular instance. So we need to enable that as well. So in here, I can mention the request should be accepted only from my IP, or it's also from anywhere. So in here, I'm going this to access from only from my IP. So it will fetch my IP automatically. Okay, now users can access via HTTP and HTTPS, and I can access the server to do the configuration. So all the rules are completed. And there is another thing. Now we need to connect a database. So now in the outbound, we need to connect MySQL request, the rule. So in here, what we need to do is we need to create another rule, and we need to connect into MySQL. Then it will automatically fetch the port. So in here, what is the destination? Who can, I mean, from this server to which component? So in here, it's not anywhere or my IP. So this should be access our other security group. Or we can say it's a database security group. So WordPress DB. So this is the destination. Okay. Now the instant, I mean, all the rules are configured in the instance security group. Now we need to do the same in the DB. So in here, what we need to do. So if we go back to the design, then the database will be accessed only from the EC2 instance. So there are no any other requests. So then we need to add a rule same as the outbound role in EC2 instance. Port is automatically connected. So this should be the instance work group or the security group. So I hope you understood about the security group rule configuration. So if I summarize, in the WordPress instance, end users has to access. So in the inbound, there should be a two inbound rule, HTTP and HTTPS. And we need to do the configuration. So we need to enable SSH. And instance should be access to the database security group. So outbound, so there should be a rule in outbound to access database. So when we discuss about the database security group, then there should be a one MySQL rule to access the instance. Okay, now then let's create a instance. So go to the instance group, then you can click launch instance. Okay, in here you can give a name, a proper name. So in here we can say WordPress instance. Then you need to give a you need to select the OS. So there are so many OS operating systems are available. So I'm using AWS given operating system AMI, and I'm not selecting the latest one, I'm selecting the previous version. So in here there is a tag to understand whether you are selecting a free tier eligible OS or the server, or you need to pay money in order to use the particular server. So I'm using a free tier, so it's a free of charge. So this is the instance type. So in instance type, you can select multiple instance based on your requirement. So if you click on this, then there are so many options available. So if you want to go with the a minimum requirement, then free tier is fine for you. So it will give one CPU and 1 GB memory. And if you want to go with the some considerable number of performance machine, then T2 large, T2 extra large. So it has 2 CPU, 8 GB memory, 4 CPU, 16 GB memory. But those are not free tier eligible host. I mean, you have to pay. So in here, it also mentioned. So this will be calculated. I mean, the cost will be calculated per hour. So if you're using a, let's say, large instance, and you are going to use Linux as operating system, then per hour you need to pay $0.1. So based on that, you can calculate your cost as well before purchasing the server. So I'm using a free tier eligible server for this requirement. Okay, now it's asking a key pair. So this is something we require to log into a server. So if we don't have a, so if we do any kind of, if we had a key, then we can reuse that key. But if there are no key, then we need to create a one key. So in here, we can give any name. So in here, I'll give WordPress. Then there are type. So based on your operating system, you need to select a particular key. So if you are using a Windows older version, then you need to go with the PPK. So it's compatible with PuTTY. And if you are using a Windows 10 and Linux or Max operating system, then you can go with the PEM key. So if you need to understand more about them, then just Google it. It will give you the more idea about this key differentiation. Okay. So I'm click PEM and create the pair. Now it's downloaded. Okay. Now in here, network setting. So in here you can create security groups, and you can create network, and you can basically you can configure the network related activity. But we have created already, so we don't need to create a group now. So just click on the select existing service security group, and I can select what is the security group I need. So I need the WordPress instance security group, so I click it. Okay, now configuration storage. So this is about the storage, how many size storage you need. So as a default, it will give you 10 GB storage, but you can go with the 30 GB with the free tier eligible band. So you can change the type as well. So I'm not going to change anything. So 8 GB is enough for me. And there are some advanced details. So I'm not going to explain it further because I mean, without changing or without configure advanced detail, we can create the instance. So I'm not going to discuss these details at the moment. So in future class, if we need to do any kind of changes in advanced details, then I'll describe it on that time. So this will give you a summary, what you are going to order, what you are going to create. So you can validate it from here as well. Okay, so I'm going to launch the instance. Instance is now ready. It's getting pending. So what I can do is, so in the downloads, let me copy this address. Okay. So easy reference, I paste that the key in WordPress and the separate folder. Now, okay. So what we can do is still, so it will take around 1 minute to boot up. So meanwhile, we can create our database as well. So if you click on, I mean, if you type RDS, then you will get this RDS, I mean, the relational database service option. So if you click on that, then you can go to that option. So in here, what I'm going to do is I'm going to create a database. From here also you can create. If you click on these databases, you can get an idea what are the running or what are the databases already existing in your account for the particular region. So I'm in Sydney. So this is a regional service. So you can have a database in Sydney, but if you change the regional to any other region, then you won't be able to see it. This is about, I mean, limited to regional service. So now I'm going to create a database. So in here, it will give you two options. Either standard creation, it's like something like you have to go with a quart number of configurations. And there's another option, you can easily create your database with few number of attributes of the steps. But I'll go with the first one, standard creation. So this is the engine option. In here, it's asking what are the database I would like to create. So in here, it has some services are given by the AWS itself, and some of the we already aware. So I'm going with the MySQL. So in here, it's asking the version. So I'm planning to install WordPress 5. So I'm going to change this my SQL version to a 5 because there may be a compatible issues. So I'm going with my SQL 5 version. So in here it's asking what is the plan, or what is the template you want to go with, either production, dev, or free tier. So in the production, you can see if you click production, there are so many options are available, like multi-available zones. You can deploy this database. Oh, there are so many available, but it will cost you. So I'm going with the free tier. If I click free tier, then all the extra option will be disabled. So in the settings, asking our database name. So I'm going with the default one, database -1. Then it's asking the credentials. So I'm going with the admin as a master username. So as for the password, I can manage my credential in the AWS secret manager. So this is a bit advanced. And I can have a auto-generate password as well. But sorry, okay, database. Okay. So I can go with the auto-generate password as well, but I'm not going with the auto-generate, but I'll create my own password. So, okay. So in here, I would like to highlight. So if you forgot about this username, or if you forgot about the database name, then you can get it from the configuration settings once the database is created. But you cannot obtain your given password. So it's not possible to edit it, but you can reset it, or you can give another new password. So if you want to, so what I want to tell you is you have to either memorize it or write it down in somewhere else if you want to use the same password you are giving in the configuration phase. Okay. Now, so instant configuration is also selected the free tier eligible storage for the class. Now this is about the storage. So in here also we can select we can go with our own storage limit, but I'll go with the default one, 20 GB. And this is about the enable auto scaling. So I'm going to untick it because I don't want that option. So in here, connectivity. So is AWS ready to connect our database with EC2 server on behalf of us? So if you want to connect, then you can select this option and you can select the whatever the server which is running at the moment. So it will create on behalf of us. But I'm not going to do that. So I'll click the first one. So network setting, yeah, I'll go with the IPv4. So it's asking the VPC. So I'm not creating any new VPC. I'm using with the default one. So default one is selected. So in here asking whether we need to access our database public or not. So if we click no, then we can't change it to public after this created. So I'm going to click on it yes, because I'm planning to connect it to a SQL developer. So you will get a better idea if we have some time. So I'll keep it as yes. So there are no any other changes apart from this. Okay, so in here, the VPC security group. So we have already created one, so no need to create a new one, but it's selected default. So I'm going to deselect it and I'm going to select what we have created. WordPress DB. So availability zone, I'm not prefer to go with any specific availability zone. So I'm clicking no preference. So I'm not going to click on the RDS proxy, no changes. So additional configuration, it will give you the database port. So you can remember that when we select the rules in MySQL, we have enabled the rules on this port. So if you want to change it, then probably we need to change the rules as well. So I'm not going to change it. So database authentication, yes, password authentication. I'm not going to give a role, so any other authentications. So monitoring, yeah, I don't need monitoring. So in additional configuration, it's asking what is our initial database. So we can give it as my DB as a initial database. So it will create a database while it's provisioning. So no need to change anything. So backup, I don't need backup. So I deselecting this option. So encryption selected, and the it's AWS manage key is already selected. So maintenance, I don't need any maintenance windows. So deselecting it. So deletion protection. It's like will prevent um, uh, accidental deletion. So if we need, we can enable it. I'm not going to enable it. So it will give you the, so it will give a summary. How much will it cost? But we have selected the free tier, so it won't cost you anything. But you have to be with the given condition. So it's giving the hours you can use the RDS and some transactions as well. Okay. Now in here as a summary, I didn't change anything. I used the default settings. So what I selected is I go with the free tier section, and so everything is perfect. Let's create the database. So normally it will take around 3 to 5 minutes. So till its provision, we can connect to our EC2 instance. Okay, now it's running. So what we need to do is in the terminal, we can okay. So when you are connecting to the server, then you should uh, have this key in your current working directory. Otherwise, it will throw an error. So if you want to know how you can connect to the particular server, then click on this connect button. In here, go with the SSH client mode. In here, it will give all the instructions how you can connect. So it will allocate your key file and go to that place, run this command in order to change the permission of the key. Then you can connect. This is the command we can use to connect. So I'm not going to do that one. So you can get an idea what will happen if we didn't change the permission. So simply I'll connect to the server using, I mean, directly I'm using, but in here it's giving the full, I mean, the IP and the DNS name, but I'm using only the IP till IP. So it doesn't matter. So you can go with the both the ways. I press the IP. Okay, okay. So in here it's showing EC2 should be IP. Let me go back to the instance. Let me get the public IP. Search I, then the key file, then the user which we need to connect, then the IP address. Okay, now it's asking to connect. Yes, then it will, the key is having the full access. What we need to do is, if we check this permission level, then it has read for every, the user, others, and the groups, but it asking to give the permission only to the user. So that's what it's mentioning here to execute this. So let me change the permission. Then I'll show you. It's now change the read only to the user. Then probably we can connect. Yes, now I'm in the server. So what we have to do? So now we need to understand what are the prerequisites. So we need to understand the prerequisites before we create this server, because for example, if we need two CPU to install WordPress, then we shouldn't go with this server, because in this server it has only one CPU. So probably we cannot install WordPress, but as per the requirement, WordPress can be installed in one CPU and one GB memory. So that's why I selected this. But if you want to get the requirement, then you have to assess this before order the server. Now, these are the steps. So I'll explain why we need to, what we need to do. So first, let me switch this to root. In here, you can see which user you are on. So these are the commands we need to run with privileged user, root user. That's why I move to root. So I'm going to check any package need to be updated. There are no package need to be updated. And here we need to install HTTPD. This is a Apache server, and PHP. And this is a PHP extension with MySQL. So we need to install these three. So I'm going to install these three. So I'll share this step with you. So in here, I'm going to download our binary file. So what you can do is, so you will be surprised how I can get this one. So you can go to this wordpress.org and get WordPress. And in here, it's showing the latest one. So either you can use this one, or you can go with the releases. So in here, you can see all the releases, even though it's past releases. So for example, let's say you need to go with 6.2, then probably if you mouse over this link, then in here you can see the URL, WordPress. So that's the URL you need to access. So in the Linux, you can use wget to download the binaries. So this is the version I will go with. This is a quite older one, but it's stable. That's why I'm going with this. This is just to demonstrate to install the WordPress. So I'm going to download it. So Okay, so it will be download to the current directory. So I'm in user home directory. So it's downloaded to the current directory. Now I'm going to unzip it. Okay, so it's zip it. So okay. Now we need to, so you may aware of that. If you want to access our web services, then the file should be moved to HTML folder. So what we are trying to do here, we are going to copy all the file and the directories which is under WordPress, move into this location. So I'm going to execute this and move the WordPress, I mean the directories and files, all the content is updated in the WordPress to HTML folder. So let me go to this directory. So now you can see, so the permission level is not defined. I mean, there are no executing permission for the user. And user is a root. So what we need to do is we need to correct the access permission, as well as we need to change this root permission to Apache. So in here chmod, we can change the permission. I'm setting it to 755. No, it's changed. And I'm going to change the owner as well to Apache. Now it's changed. So all the things are done. Now I need to start HTTPD server. I mean the Apache, we need to start service. I'm going to start it and I'm going to enable it. So we can check the status. Then we can see service is active and running. Now our WordPress is now we place the, download the WordPress required file and we place it to the particular folder. And to execute this WordPress, we need PHP, Apache, and MySQL extension. So we install that. Now everything is done. Now the remaining part is we need to install WordPress. That's all. So before that, let me check. Okay, now it's provisioned. So let me click on this database. So okay, now our database is now created. So if you click on this connectivity and security, the first tab, then you will see the endpoint, port, and the network related details and security related details. Actually, we don't much need this information at the moment. We need endpoint URL and the port. And if we go move to configuration, then you can see the engine version or the MySQL version, DB name, and the username, so cannot be changed. And so now, so in here, so let me move into here. So EC2 server is now ready. We have created the security group. MySQL is now ready. We have defined the security group as well. Now what we need to do is we need to install this WordPress. So what we can do is we can access this instance from web browser and we can do the installation. So if you click this web the instance, then under details you can get the public IP. This is the one we use to access it the server as well. So here probably, yeah, now it's accessible and WordPress installation is enabled. So if we go with the continue, okay. in here, we need to define the correct value in order to connect to the our RDS database or the MySQL database. So in here, database name, it's MyDB. So in here, you can get the details if you can't remember. It's MyDB. And username is admin. Password, actually, I can't remember it, but let's see that. Database host. So in here, connectivity and security, you can get the endpoint. So we don't need to change it because it's asking to change only if you are using multiple WordPress installation. So if we couldn't able to connect, then probably the version, database version is not compatible. So either we need to delete our database and go with the correct versioning, or else we need to remove our WordPress and go with the correct version WordPress. Okay, now this is matching. So it's give the installation page. So let's install it. Okay, now the connectivity completed. In here, it's about the WordPress application. So simply I'll give you the WordPress username Mohan. Password, I'll select the same password. Okay. Okay, I'll use a dummy email address. So everything is fine. So I'm going to log in using the credential I have created. Okay, now installation is completed. So I can access the WordPress. So all the security groups, instance, and the services all are correctly configured. That's why I can see this page. So since we have some time, so I'll try to connect from the SQL developer. So this is a simple application. This is an open source one. You can download it from the internet as well without no cost. So let me try to connect to the database from here. So in here we can give you the WordPress name. So SQL admin. Okay, so it's getting okay, it's getting timeout. So what would be the reason why it's giving a timeout? So if we think about this setup, so end users can access EC2 instance, SSH is enabled for my IP only, and RDS is security is controlled to accept request only from EC2. So this is the issue because it's not enabled from outer world to access. So what we can do is simply we can go back to the security group, and in the WordPress DB security group, we can add one more rule. So it will be the same as above MySQL connectivity, but it's only from my IP. I can give it to anyone, or the what do you call that, to anyone from the world. So in that case, everyone can connect to my database using their SQL. So I'm giving only for my IP and save the role. Then let me test it. It's connected now. So let me save it and let me connect. So this is the initial database we have created. And as a easy reference, I'll since there are no any data in my database, so I'll click on this WP users. So in here, I can see the existing user which I created as an initial phase. So what we'll do is I'll go back to my website and let me add another user. So in here also I can see the same user. So let me add one more user. Username, admin user, first name, admin, password. I'll select the same password, ABCD. And the role, I'll select this as a contributor. Then add new user, email, admin. Okay, so there. Now admin user is added to our database. So let me go from here and execute it again. Then I can see this admin user. So this is the new record which we got. So if you want to access my server, if you use this IP from your browser, then probably you can access it. So you will see the this website. So since you saw my username and password, so you can log into the WordPress as well. So if you click on this and press admin, as I remember, then you can maybe I'm logging as admin, it's not letting me know. But if you can, I mean, if you access this IP, then probably you will see this website. Then again, if you want to do, if I want to private, I mean, I want to limit this access, then probably what I need to do, simply I need to go back to the security groups, and in the instance, I need to change these rules. So simply, if I change this source from anywhere to my IP, then you can't access my site. It's only limited to me only. So like that, we can change the access level as well. So this is the demonstration. What we, if I summarize what we have done, I have created EC2 instance, and I have installed WordPress. Then I have used a service from AWS to use MySQL. And we have created two security groups, and we have created the appropriate security rules to limit the permission. Then we let end users or the customers to access our EC2 instance of the website via HTTP or HTTPS. And we have enabled SSH to do the configuration. Then what we have to do is we have create this RDS as a public in order to connect with the SQL developer. So this is the configuration the activities which we have done. So if you have any questions, I can answer. So let me check any. Yeah, there are no questions. So if you have any questions, please share in the WhatsApp group. So we can answer when we are free. As well as I'll share this command line. So you will get an, so since I describe it, you know what is this about. And if you want to change it slightly, like if you want to go with the latest WordPress, and if you want to use latest MySQL, then you can change it. And you know now how to change the permission and how to change the users as well. So I hope, since there are no questions, I hope you understood it very well. So let me, yeah. So yeah, that's all. Thank you very much.